Hello and welcome to Kim Academy, video by Nathan Lau, Benny Lin, and Kimberly Yu. Today we are going to discuss about parametric equations. Now, what exactly are parametric equations? They help us determine x and y in terms of the variable t for time. So the parametric equation for x and y in feet per second are x equals initial v times cosine of theta times t, and y equals negative 16t squared plus initial v times sine of theta times t plus h.
Let's take for example Nathan, a baseball player that hits a baseball at a height of 4 feet off the ground. The ball then travels at an initial speed of 100 feet per second at an angle of theta equals 45 degrees. In terms of an x and y diagram, theta would still be 45 degrees, the ball traveling at 100 feet per second, which leaves us with the question of x and t. We need to look for the maximum distance traveled, which is x, and t, the amount of time the baseball is in the air.
So how do we solve for x, the maximum distance, and t, the time it takes to get there? So first we would need to write out the parametric equations for x and y. So the general formula for x is equal to the initial velocity times the cosine of theta times t. Now you would just plug in the numbers we already know, because we know initial velocity and theta. So x would be equal to 100 times the cosine of 45 degrees times t. And then after that, because we know that cosine of 45 degrees is equal to root 2 over 2. So to simplify, you would just multiply 100 times root 2 over 2. And that is 50 root 2 t. And that is the general equation for x. It doesn't matter that we don't know t, we'll find that later. And then y is equal to negative 16 t squared plus initial velocity sine theta t plus h. Now this one's slightly longer, but the principle remains the same. All you have to do is plug in the numbers you already know and simplify. So the general equation for y is equal to negative 16 t squared plus, now we know that the initial velocity is the same and theta is still equal to 45, but sine and cosine of 45 both equal root 2 over 2, so that the middle part of this y equation would be the same as the x one. So plus 50 root 2 t plus 4, which is the initial height we start at. So in order to solve for the maximum distance, we need to set y equal to 0, so because that's the amount of time that the ball stays in the air. So 0 would be equal to negative 16 t squared plus 50 root 2t plus 4. Now we're going to have to use the quadratic equation for this, and it's going to get messy, but unfortunately, there's nothing else we can do. So the general formula for the quadratic formula is t is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. Just a little reminder for those of us who have forgotten. So plugging in the numbers into the equation, you get that t is equal to negative 50 root 2 plus or minus the square root of 50 root 2 squared minus 4 times negative 16 times 4. All of this is over 2 times negative 16. And when you solve for this, you get that t is either equal to negative 0.056 seconds or 4.475 seconds. Now, the reason why we would get a negative extraneous answer is because that our initial time 0 starts at the height of 4. And if we followed the parabola backwards, we would get that y would equal 0 again a little bit behind the time we started at, but we don't need that and that's extraneous, but that's just why we have a negative time. So the time we would use and the time it takes to reach maximum distance and the time it takes for the ball to stay in the air is 4.475 seconds. Now to solve for the maximum distance, you would simply plug this into the x parametric equation. So remember the formula for this is x is equal to 50 root 2 t. So you would just plug in the answer and you would get x is equal to 50 root 2 times 4.475, and you would get that the maximum distance for x is equal to 316 feet. And that is the maximum distance the ball will go given these initial starting conditions. And that is how you solve for the time and the distance in this situation. And so thank you for watching our introduction to parametric equations, and we hope that you join us again on Chem Academy. Thank you.